Bohr seems to think, I don't know how to reconstruct this in a rational way, but Bohr seems to think that there's a tension between, on the one hand, this sort of, I don't know if it's a priori or analytic, some kind of very deep necessity of describing experimental procedures in thoroughly classical terms, on the one hand, that if you don't do this, you just can't imagine how to do science, okay? Why that should be true, I have no idea. Clearly, by the time we get to von Neumann, he's not thinking in those terms. He's trying to describe everything in terms of quantum mechanical wave functions. It's just that he has this Frankensteinish theory about how they change with time, okay? But Bohr thinks there's this really deep tension between, on the one hand, the necessity of describing and reasoning about and communicating about experimental setups and outcomes in purely classical terms, and on the other, the inadequacy of classical physics to treat the sort of phenomena that we are confronted with in atomic physics, as he says, okay? And he thinks that this is a tension that anybody who reads this as a tension that we got to figure out how to resolve is already making a mistake, okay? That anybody who sees this rightly, don't ask me to defend this claim, but this is how I'm reading what Bohr writes. Any attempt at reconciliation, any attempt at sewing these things together a la Frankenstein or something like that is already a radical mistake. Okay, that we should have learned that any such attempt will, for reasons that only Bohr can see, inevitably collapse into hopeless paradox. Okay, or something like that. Okay, and that once you see this, you're going to move from an idea of the aspirations of physics as doing what Tim calls solving the reality problem, okay, telling us what the world is like, to a much more modest, much more instrumentalist in philosophical terms conception of the aspirations of physics as telling us how certain measurements are going to come out, and with a strong caution not to speculate any further than that, because that way lies madness. That way lies collapse into hopeless paradox that you're never going to find your way out of. You're absolutely right that what Einstein would say to that, and rightly so, especially given the way subsequent history is gone, what Einstein's going to say is, gee, are you sure about that? I mean, are you sure this is going to inevitably collapse into hopeless paradox? Because it turns out nowadays, we know by explicit construction that that's not true, okay? We have a bunch of solutions to the measurement problem that work at least for the sort of non-relativistic quantum mechanical phenomena that Bohr and Einstein were discussing at the time, a la the GRW theory, which you mentioned, or Bohm's theory, which we haven't mentioned yet. So sure, I agree with that. But I think Bohr's view was anyone who saw this rightly saw that this was not a problem to be solved, okay? This was a confrontation with the limits of the depth to which the scientific imagination could even in principle penetrate.
Okay, so let me, and again, I hadn't anticipated this devolving into Bohr exegesis, but which is, I think, kind of a hopeless task. But let me at least put a couple data points or possible observations here. So one thing you said was that you were very puzzled about why Bohr would insist that the experiment be described in classical terms, right? And there are two ways of hearing that demand. And in one way, I don't think makes any sense at all. And the other way, I think, does make sense. the way that doesn't make sense at all is if you think by in classical terms, I mean using classical dynamics like Newtonian mechanics. That is using classical dynamical principles, F equals ma. But it seems to me that's not what he needs to mean. I'm not sure if he was clear about this. But suppose I do an experiment and you just ask me, okay, what did you just do, right? Describe the experiment to me. And I say, well, I took a little piece of uranium and I stuck it here and I put a big spherical shell around it. And I waited to see when a spot formed and where it formed. Now, that description doesn't involve any dynamics. I mean, I haven't postulated Newton or anything else. It is, in a certain sense, in classical terms, that is, in the positions and behaviors of macroscopic objects, right? And I mean, this is the sort of thing that Bell talks about. When I describe the experiment, I have to say, these switches were switched this way, and this much current was running through these wires.
But I don't know.
And I can, let me just finish it. Yeah. I can see all that without specifying the dynamics. But if I can't even use that language in describing the experiment, then I don't know how to get across what I even did. And you can sort of see how physics would devolve into a Tower of Babel if I'm not allowed to say that kind of stuff.
Yeah, but I think somebody like von Neumann would already have said, what's the impediment to understanding everything you just said as approximate descriptions of quantum states of various macroscopic systems, as opposed to approximate descriptions of locations in classical phase space? This has nothing to do with dynamics.
I'm not sure how that conversation would go, but let me just give one other data point, which is that the Bohr you imagine is a very modest guy, right? He says, look, we've reached the limits of what the human mind can accomplish. We shouldn't try to go beyond those limits.
Right.
You know, the ship will sail over the edge of the world or something.
Right.
But there's this other part of Bohr which I don't see how to reconcile with that. And that's, he thought that this principle of complementarity that he had discovered was the fundamental mystical key to all of reality, that it applied not just in quantum mechanics, but everywhere, that the concepts of life itself was complementary, of being alive was complementary to having a precise description of the cellular workings, right? The idea was something, if you set up a situation where you can figure out what the cell is doing, you of necessity have to kill it. Now that, of course, just turns out to be completely ridiculous and absolutely wrong. And we know by electron scanning microscopes and what we can do nowadays, that's just completely idiotic. But Bohr said it, right? And Bohr not only,
but
it was profound, right?
First of all, I agree that
family seal that he did. So that's not a modest, like, I'm not going to make deep claims about the world guy. That's a,
no, I mean, look,
about the world you can imagine.
I agree with you that it's probably not the most productive direction for this conversation to go to devolve into Bohr exegesis. But I'll just say quickly and then drop it. I don't see any tension between what you just pointed to about complementarity being an extremely broad business and the way I was reading Bohr here. But forget about that. The way Bohr came up here is by way of my explaining that what the term the measurement problem evokes for me, okay, is a very deep debate about what one could hope for from the scientific project, okay? Even deeper than a debate of the form, what are the deliverances of a properly conducted scientific project about whether the world is made of waves or particles and waves, or, you know, what the fundamental ontology is. That's the answer to the reality problem. I saw what was at stake in the measurement problem as a question about whether science could even aspire to answer what you're calling the reality, to solve what you're calling the reality.
Maybe this can be the last comment on this topic and we can go somewhere else. On your reading of this, I take it, you then think the measurement problem is over and done with. It's set.
Yeah. In a certain sense,
there's nothing left of it, right? These actual constructive theories,
right,
that what Bohr said couldn't be done,
right,
are object lessons that show he was just wrong, and we really don't.
I'm this construal of the
just wrong, right?
Exactly right. I agree. Yeah.
Okay. Good. I think we can leave Bohr aside at this point. Then, I mean, if you think his conclusion was wrong, it doesn't really matter how he got there.
Good.